Hello students and welcome to part 2 of lesson 7. Let's look at one more example of two solutions and then we will move on to look at some examples of one solution and no solution. Now if we take a look at our equation, we see that it's equaling a positive number and we see that the absolute value symbols are already isolated. Everything that exists on this left side of the equation is inside or grouped by the absolute value symbols. We also see now, this is step 2, that when we observe what the absolute value symbols equal, that it equals a positive number. That means there will be two solutions. So we know that the value inside of the absolute value symbols, which is 2x minus 2 in this case, is either positive 8 or negative 8 away from 0. Since it could be equal to two numbers, we need to make two equations. 2x minus 2 is either positive 8 or 2x minus 2 is negative 8. If you need to, you could create a do and undo chart. If you knew what x was, you'd have to multiply it by 2 and then subtract 2. So to undo it, we'll add 2 and divide 2. Some of you may not need that any longer, and that's okay. To get rid of our constant of negative 2, we'd have to add 2. Negative 2 plus 2 makes 0. If we add 2 to one side, we have to add 2 to the other. 2x plus 0 is 2x, and 8 plus 2 is 10. Now our second step, we'll have to divide by 2 to create a coefficient of 1. 2 divided by 2 is 1. 1 times x is x. 10 divided by 2 is 5, so x is 5. We need to isolate the variable on this side as well, which will use the same inverse operations since it contains the same algebraic expression. And when we do, we get x is equal to negative 3. So for this equation, x is either 5 or x is negative 3. And we can still check our answer. 2 times 5 is 10 minus 2 is 8. How far away from 0 is 8? 8 away. Put negative 3 in. 2 times negative 3 is negative 6. Minus 2 makes negative 8. How far away from 0 is negative 8? 8 away. Now let's look at some one solution examples. And we know that these occur when our absolute value symbols equal 0. So here is an equation where the absolute value is equal to 0. We can see that the absolute value symbols are already isolated. So we know that what's inside the value that's being absolute, that has the absolute value symbols, has to be 0 away from 0 or equal 0. So then just isolate your variable and we get x is equal to negative 1. And you can substitute back in and see that it makes sense. Negative 1 plus 1 makes 0. How far away from 0 is 0? 0 away. Now, I strategically picked this example because if you do not choose to isolate the variable and you look right here from the start, it looks like it has two solutions. And that's why it's very important to be sure that you've isolated that absolute value before you make any decisions on what type of solution it may have. Do you see how the absolute value symbols are not alone on this side of the equation? After the amount's absolute valued, it is adding 4. So we have to take 4 away from each side in order to isolate the absolute value symbols. So the absolute value of x plus 4 equals 4 minus 4, which is 0. Now we can see that this has one solution because the absolute value symbols are isolated to equal 0. So that means that what's inside is equal to 0. And then we just need to use inverse operations, which in this case is just one step, in order to isolate the variable. So we get x equals negative 3. This is the only value of the variable that will make this equation true, and you can substitute back in if you want. Negative 3 plus 3 is 0. How far away from 0 is 0? 0. And 0 plus 4 is 4. It indeed makes the equation true. Let's look at one more example of one solution. Ask yourself, is the absolute value symbol isolated? The answer is no, because it's subtracting 8 afterwards. So we have to add 8 to each side. Negative 8 plus 8 makes 0, so we get the absolute value of x plus 2 being isolated, and that's equal to negative 8 plus 8, which is 0. Now that we have the absolute value symbols isolated, we can see that it's equal to 0, which means there's only one solution, and that is that what's inside is equal to 0. So if we isolate the variable, we get that x is equal to negative 2. This is the only value of the variable that will make this equation true, and you can substitute back in to see if it makes sense. Negative 2 plus 2 is 0. How far away from 0 is 0? 0, and 0 minus 8 is negative 8. Now let's look at some no solution examples. Remember, we know that no solution occurs when the absolute value symbols are isolated to equal a negative number. Now, look at this equation. Are the absolute value symbols isolated? No, they have plus 8 with them. So to subtract 8 from each side, positive 8 minus 8 makes 0, so we get x, absolute value of x plus 2 on this side, is equal to 5 minus 8, which is negative 3. Can a distance be negative? No. So this has no solution. There is no value of the variable that you could ever put inside of there to get an absolute value of negative 3. Let's look at another example. Are the absolute value symbols isolated? No. They actually have two operations with them. Do you see how we have a 2 here? A positive 2? How do we eliminate positive 2? Well, we subtract 2. Positive 2 minus 2 makes 0. We have negative absolute value of 2x minus 5 is equal to 7 minus 2, which is 5. Well, when we see a negative sign touching a grouping symbol, that's really multiplication of the number negative 1. So to eliminate multiplying negative 1, we'll have to divide by negative 1. So when we do, we get the absolute value of 2x minus 5 is equal to negative 5. Now we see that the absolute value symbols are isolated to equal a negative number, which means there's no solution. There is no value of x that we could ever put in there that when absolute valued would equal a negative number. Alright, let's look at one real-world situation, then we'll summarize what we've learned. A quality control inspector at a bolt factory examines random bolts that come off the assembly line. Any bolt whose diameter differs by more than 0.04 millimeters, that's 4/100ths of a millimeter, from 6.5 millimeters, which is 6.5 millimeters, is sent back. Let D equal the diameter of a bolt. Solve the equation absolute value of D minus 6.5 is equal to 0.04 to find the maximum and minimum diameters of an acceptable bolt. So let's write down our equation that they've given us. We can see that the absolute symbols are isolated to equal a positive amount. That means that what's inside could be positive or negative 0.04. And all that means is that the bolt size can be either 4/100ths more than 6.5 or 4/100ths less than 6.5. So we know that the difference between the size of the bolt and 6.5 could be up to 0.05 more, or the difference between the diameter of the bolt and 6.5 could be up to 0.4 less than 6.5. Now if we use inverse operations, we'd have to add 6.5. Notice I lined up the decimal points. Negative 6.5 plus 0, or 6.5 makes 0, so we get D equals, and then we add those together to get 6.54. This would be the maximum. Now if we add 6.5 to each side here, negative 6.5 plus 6.5 makes 0, and we get D equals. We have different signs, we're going to have to find the difference. Put the larger amount on top, 6.50, and take away 0.04. Regroup if necessary, 6.46. Now, we can restate our answer. What are the maximum and minimum diameters of an acceptable bolt? So an acceptable bolt can be as small as 6.46 millimeters and as large as 6.54 millimeters. So let's summarize what we've learned. There are three different types of solutions to absolute value equations. When the absolute value symbols are isolated, remember we have to isolate the variable before we can make any decisions. If the absolute value equals a positive number, there will be two solutions. If the absolute value equals 0, there will be one solution, and if the absolute value equals a negative number, there will be no solution. We also learned the steps to solving the absolute value equations. We learned that we should first isolate the absolute value symbols, then observe what type of solution it will have, and then do one of three third steps. If two solutions exist, understand that the value inside could be positive or negative. Then create two equations that can be used to find two solutions and solve. Now, if we know that only one solution exists, we'll set the value inside the absolute value equal to 0 and solve. Or, if no solution exists because the absolute value equals a negative amount, write no solution.